Hello dear students, in last lecture we are studying about the synthetic applications of methyl magnesium iodide, and the next one application is in the preparation of aldehydes. We can use the methyl magnesium iodide in the preparation of aldehyde also, and here I am writing the general reaction RMgX, that is a Grignard reagent, when it is treated with hydrogen cyanide HCN, and here in the hydrogen cyanide the carbon is having a partial positive charge and the nitrogen is having partial negative charge, because the nitrogen is more electronegative than the carbon, and hence it will drag one bonded pair of an electron towards itself, and hence the carbon becomes electron positive, and this electropositive carbon then attacked by an electron rich organic group of the Grignard reagent, and hence it forms HCr double bond N minus, and this MgX will attach with the negatively charged nitrogen by an electrostatic force of attraction, and this is an unstable intermediate, and this unstable intermediate on acid hydrolysis, the hydrogen of water molecule will combine with the nitrogen and forms HC double bond NHR, and the OH of water molecule will combine with the MgX and forms OH, and this one is called aldimine. This compound is called aldimine because it is very similar to the aldehyde, that is RC double bond OH. The only difference here is instead of oxygen NH group is there, therefore it is called aldimine, and this aldimine on acid hydrolysis, gives HCr double bond O, that is aldehyde plus NH3. Here this NH and the two H's from the water forms an ammonia. This is the preparation method of aldehydes by using the Grignard reagents. Okay. And here I will write one example by taking methyl magnesium iodide as an Grignard reagent. When methyl magnesium iodide is treated with hydrogen cyanide, this methyl group will attach with the electrophilic carbon, and one of the bonded electron pair will shift towards the nitrogen and forms a negative charge on it, CH3 double bond N minus Mg plus I, and this intermediate on acid hydrolysis forms HCCH3 double bond NH, an aldimine along with the IOH, and this aldimine on once again hydrolysis in presence of acid as a catalyst forms HC double bond O CH3. This one I will rewrite as a CH3 C double bond O H. This is an aldehyde, that is acetaldehyde along with ammonia. This is the preparation method of aldehydes by using methyl magnesium iodide. Okay. And here the next application is in the preparation of ketones. Whenever the Grignard reagents are treated with any nitriles other than the hydrogen cyanide, when the Grignard reagents are treated with any nitriles other than the hydrogen cyanide, we will get ketones. See here also, this nitrogen being a more electronegative atom will drag one of the bonded pair of electron towards itself, and hence the organic group of an Grignard reagent will attack on an electrophilic carbon and forms R dash C R double bond N minus MgX, and this intermediate on acid hydrolysis. And here in some book they are writing this H2O bar H plus as an H3O plus, no doubt both are same only. On acid hydrolysis, the hydrogen of that water will combine with the nitrogen and forms ketimine. Ketimine. In aldehydic preparation it is forming aldimine, and here it is forming ketimine. Here the only difference is there with the position of oxygen. R C double bond O R dash is an ketone, and R C double bond NH R dash is an ketimine along with MgXOH. Okay. And once again, when this ketimine undergoes an acid hydrolysis, forms ketone with the loss of ammonia. Okay. And here I will write one example for this one by taking methyl magnesium iodide. When the methyl magnesium iodide is treated with methyl nitrile, when the methyl magnesium iodide is treated with ethane nitrile it is, or we can call this one as an methyl cyanide. When the methyl magnesium iodide is treated with methyl cyanide, it will form CS3 CS3. This methyl group will attack to this carbon, double bond N, negative charge Mg plus I, and this on acid hydrolysis forms CH3 C CH3 double bond NH plus MgOH I, and this ketimine on further hydrolysis in presence of an acid as a catalyst gives C double bond O CH3 acetone. This is our desired product ketone. We can call this one as an propanone plus NH3. Okay. This is the preparation method for the ketones by using methyl magnesium iodide. And here you can ask how this second hydrolysis takes place on this carbon nitrogen double bond. See here, I will explain here that one. Here I am taking this one, or this one take as an R dash C double bond NH R, and this nitrogen is having one lone pair of electron, and it will abstract the proton which is there as a catalyst and forms a new bond with this one R dash C R double bond N H2. Then this nitrogen with 4 bonds, now it becomes unstable, and it will drag this bonded pair of electron towards itself and becomes stable with only 3 bonds and a pair of electron, lone pair of an electron. And now the carbon, after losing this bond, it will having only 3 bonds, and it will get a partial positive charge, and that partial positive charge can be stabilized by the lone pair of electrons present on the oxygen of an water molecule. Then R dash C O H H NH2 R, and here this oxygen now it is having 3 bonds, and hence it will have a positive charge, and this nitrogen of the NH2 group which is having a pair of electron will abstract proton, and this bond will shift towards the oxygen carbon bond, and hence here the carbon which is having or which is forming a new bond it now becomes unstable because it is having 5 bonds, and it will break this carbon nitrogen bond, and after the loss of NH3 NH2 H NH3 we will have R dash C R double bond O H, and now also the oxygen is having positive charge because it is having a 3 bonds, and after the deprotonation, that is a loss of proton we will have R dash C double bond O R ketone. Okay. This is the reaction mechanism for the addition of water to the carbon nitrogen double bond. Then the next application of the methyl magnesium iodide is in the preparation of esters. in the preparation of esters. When the Grignard reagent is treated with ethyl chloroformate, that is a Cl, C double bond O, O, C2H5, it is called what? Ethyl chloroformate. When the Grignard reagent is treated with ethyl chloroformate, this carbon which is connecting to 3 electronegative atoms is having an electron deficiency and will be attacked by an electron rich organic group of the Grignard reagent and forms Cl, C, R, O, C2, H5, and this carbon after the formation of new bond with the organic group, that is R, is having 5 bonds and it becomes unstable, and therefore it will shift this one of the pi bond towards the oxygen, and hence the oxygen becomes negative and it forms an electrostatic force of attraction with the Mgx. And now here the negative charge which is present on the oxygen will be back bonding towards the carbon oxygen single bond, and the carbon will lose Cl, and this Cl will combine with Mgx and liberates as an MgClX, and now here we will have C double bond O, R, O, C2, H5. I will rewrite this one, R, C double bond O, O, C2, H5. This is an ester, correct? This is the synthetic application of Grignard reagents in the formation of ester, and I will write the mechanism for methyl magnesium iodide. This is an ethyl chloroformate and it forms an new bond with the organic group of the Grignard reagent OC2H5, and here after the loss of chloride I will have CH3, C double bond O, O, C2, H5 plus Mg, sorry here I have to write I, Mg I plus Cl, and its name is ethyl acetate. It is a synthetic application of Grignard reagent in the preparation of esters. Okay. Then the next one application is in the preparation of carboxylic acids. In the preparation of carboxylic acids, whenever the Grignard reagents are treated with carbon dioxide, the organic group of the Grignard reagent will attack on the carbon of an carbon dioxide, because this carbon is having an electron deficiency because it is attaching to a 2 electronegative atoms, that is oxygen atoms, and therefore this group will attack on the carbon, and the oxygen, one of the oxygen will drag a bonded pair of electron towards itself, and here O double bond C R O minus Mgx, and this on acid hydrolysis, it is an intermediate addition product, and this on acid hydrolysis forms R C double bond O O H. The H of water will combine with the negatively charged oxygen, and the OH of the water will combine with the Mgx. This is our carboxylic acid. For example, when methyl magnesium iodide is treated with carbon dioxide, methyl group will attack on the carbon of an carbon dioxide and forms a new bond with carbon of an carbon dioxide minus Mg plus I, and this on acid hydrolysis H3 C double bond O OH plus Mgi OH. This is an carboxylic acid, that is a acetic acid, correct? This is the synthetic application of methyl magnesium iodide in the preparation of carboxylic acid. Then next one is the preparation of amines, and whenever the Grignard reagents are treated with chloramines, whenever the Grignard reagents are treated with chloramines, which is having a formula of NH2Cl, chloramine, it is called what? Chloramine. Whenever the Grignard reagents are treated with chloramines, CHLO, chloramines, this chloride, which is more electronegative as compared to the nitrogen, will drag this bonded pair of electron towards itself, and hence the nitrogen becomes electropositive, and this organic group will attach to this nitrogen and forms RNH2 plus MgXCl. This organic group will attack to the nitrogen. For example, when methyl magnesium halide is treated with chloramine, this methyl group will attach to the nitrogen and the chloride will leave the chloramine, and it forms NH2 plus MgICl. This is a methyl amine. Okay. This is the preparation method for the amines by using methyl magnesium iodide. And the next application is in the preparation of alkanes. And here there are two methods to prepare the alkanes by using Grignard reagents. The first one is by reacting Grignard reagent with compounds containing active hydrogens. The alkanes can be prepared by reacting Grignard reagent with the compounds containing active hydrogens. The compound containing active hydrogens means what? Acidic hydrogens. Acidic hydrogens. For example, water, alcohol, ammonia, etc. These are some of the examples for the compounds which are containing active hydrogens or acidic hydrogens. Active hydrogens or acidic hydrogens means what? These compounds can easily donate H plus ion. Okay. And whenever the Grignard reagents are treated with these type of compounds, here I am taking water as a source of active hydrogen. This negatively charged organic group of the Grignard reagent will abstract the proton from the proton donor. Of the Grignard reagent will abstract a proton from the water molecule and forms an alkane, and here it is abstracting the proton and it is acting as an base. Now what we have discussed up to the preparation of amines, in all the cases the R group of the Grignard reagent is acting as an nucleophile, but here this Grignard reagent is acting as an base and abstracting a proton, and therefore we can call this one as a type of an acid base reaction. It is a type of an acid base reaction, and here the Grignard reagent acting as a base and abstracting a proton from the compounds containing active hydrogens MgXOH, or see once again R MgX plus ROH alcohol, and this will abstract a proton and forms alkane MgX plus R dash, or RMgX plus NH3. Here the R group will abstract any of these three hydrogens from the ammonia and forms an alkane, MgX plus NH2. For example, when methyl magnesium iodide is treated with water, this methyl group will abstract this proton and forms methane CH4, and here we will have Mgi plus OH. And when methyl magnesium iodide is treated with methanol, this methyl group will abstract this proton and forms methane MgIOCH3. When the methyl magnesium iodide is treated with ammonia, it forms methane and MgINH2. Okay, this is the one type of preparation of alkanes by using a Grignard reagent, and the second type is by reacting Grignard's reagent with alkyl halides or alkyl sulfates. By reacting Grignard reagents with alkyl halides or alkyl sulfates, take for example, when methyl magnesium iodide is treated with methyl iodide. When methyl magnesium iodide is treated with methyl iodide, that is alkyl halide, it forms CS3. Here this methyl group will attack on the carbon, and this group will, that is iodide, will leave the methyl iodide and forms a new bond between the carbon and carbon. This is an ethane, that is alkane, and MgI, and we can write methyl magnesium iodide when treated with dimethyl sulfate, S double bond O CS3. This is dimethyl sulfate. Here this methyl group, and in this case the organic group of the Grignard reagent, now it is acting again as a nucleophile. Okay, but in the previous case, that is by reacting Grignard reagent with the compounds containing active hydrogen, this group is acting as a base, but here it is once again acting as a nucleophile and attacking on the electrophilic carbon. This carbon is electrophilic in nature. Why? Because this oxygen is dragging this bonded pair of electron, and hence the electron density on this carbon is decreasing, and here we are getting ethane plus MgIOSO3 CH3. Okay, this is all about the synthesis of alkanes by using the methyl magnesium iodide. Okay, or broadly we can say that whenever the Grignard reagent or the methyl magnesium iodide is treating with formaldehyde, we will have primary alcohol. When it is treating with any aldehyde except formaldehyde, we will get a secondary alcohol. When it is treating with ketones, we will get a tertiary alcohol. And when it is treating with hydrogen cyanide, we will get aldehyde. When it is treating with any nitriles except the hydrogen cyanide, we will get ketones. And when it is treating with ethyl chloroformate, we will get esters. When it is treating with carbon dioxide, we will get carboxylic acids, and when it is treating with chloramine we will get amines, and when it is treating with compounds containing active hydrogens we will get alkanes. Okay. Thank you.